left, and those are cotangent and tangent. We're going to start with cotangent, and we're going to go ahead and graph it based off of our unit circle. So if you pull out your unit circle, you should hopefully have tangent values written all along the sides of your angles. So looking at those tangent values, we're just going to take their reciprocal. So at 0, the tangent of 0 degrees, or 0 pi, is 0. The reciprocal of 0 then, because I really want cotangent, the reciprocal of cotangent is going to be undefined. Tangent is 0, cotangent is undefined. Continuing around our circle at pi over 6, tangent is root 3 over 3. So cotangent is going to be 3 over root 3, which I'm just going to go straight to decimals. It's about 1.73. At pi over 4, tangent is 1, reciprocal of that is still just 1, so the cotangent is 1. At pi over 3, tangent is root 3, so cotangent is 1 over root 3, which again is a decimal, is about 0.58. At pi over 2, tangent is undefined, so cotangent is 0. At 2 pi over 3, tangent is negative root 3, so cotangent is negative 1 over root 3, which is negative 0.58. And my numbers are going to, again, start to repeat into the negative. So at 3 pi over 4, cotangent is negative 1. At 5 pi over 6, cotangent is negative 3 over root 3, which is about negative 1.73. And at pi, cotangent is undefined. I'm going to continue on to the second half of our circle into quadrant 3. Cotangent is 1.73, 3 over root 3. 5 pi over 4, cotangent is 1. 4 pi over 3, it's about 0.58. At 3 pi over 2, tangent again is 0. Tangent is undefined, so cotangent is 0. At 5 pi over 3, we're at negative 0.58. At 7 pi over 4, we're at negative 1. 11 pi over 6, negative 1.73. And at 2 pi, tangent is 0, and therefore cotangent is undefined. Okay, so once again, all of those numbers came from my unit circle. If I want to go ahead and graph all these values, we have an x and y axis down here at the bottom. And I'm going to graph my very farthest point to be 2 pi, because that's how far I have values up until. Half of that is pi, half of that is pi over 2, and 3 pi over 2. And again, I have a lot more values than just those 4. So if I start here at 0, I'm just going to add a few more. This would be about pi over 4. This would be about pi over 6, pi over 3. Here's 3 pi over 4, just to give us some more values to look at. If you look back to your table, the highest cotangent value you have listed is about 1.7. So I'm going to go ahead and mark, here's 1, we'll go up to 2, down to negative 1, and down to a negative 2. Okay, if I go ahead and start to graph this, at 0 I'm undefined. So remember, how do I show something to be undefined? I draw an asymptote. So cotangent is undefined at 0. At pi over 6, we were at about 1.73. At pi over 4, we were directly at 1. At pi over 3, it was 0.58. Pi over 2 is when I directly cross that x-axis at 0. At 3 pi over 4, let's jump to that, we were at about negative 1. 5 pi over 6, about negative 1.7, and let's throw in 2 pi over 3 was like negative 0.58. Okay, and as you notice, this is starting to look like a line. Be careful though when you start to connect it. It's actually going to be more of a curved line that looks like so. And again, we only had a couple points to go off of. So if you had a few more, it would look a little bit more onto that curved shape. It almost looks like the equation of a cubic, kind of going in the opposite direction, but if you can think about x cubed, that's sort of what it looks like. At pi, let's continue with our graph here. At pi, we were undefined again. So I want to put another vertical asymptote. At 3 pi over 2, we were at 0. And at 2 pi, again, I was undefined. So I'm kind of jumping ahead into some of those x coordinates there. And let's go ahead right in the middle of pi, and 3 pi over 2 is at 5 pi over 4. We're at 1. And right in the middle of 3 pi over 2 and 2 pi, we're at 7 pi over 4, which is also at 1 but in the negative direction. And again, those values are the same as they were on my first row up on the top. So you're going to end up getting the exact same looking graph. Okay, a couple things to notice here. Your period is going to be different. This is the first time it's different than sine, cosine, secant, and cosecant. One graph, before it starts to repeat itself, is now fitting just from 0 to pi. So here, my period is now pi. As you can see, I have one curved line, asymptote, and then the graph repeats itself again, so I don't want to include all the way to 2 pi. That would be 2 periods. I'm going to just stop at pi. My amplitude, once again, I can't measure this. I don't have a center of the wave that I can measure to the top and to the bottom. So similar to secant and cosecant, we're just going to say none. I don't have a distance I can measure. There's just no amplitude by definition according to our cotangent graph. Your domain is going to be all reals, but again, the minute you have vertical asymptotes, you're giving yourself restrictions. So it cannot equal 0. It cannot equal pi. It cannot equal 2 pi. Those are values that I can't get anything out for. So again, pick an asymptote. I'll pick pi. All reals except pi plus how far do you have to go until you hit another asymptote? Well, this time, I'm only going to travel from pi to 2 pi, or from 0 to pi, which is a distance of pi n number of times. And remember, for secant and cosecant, that distance that I traveled was always half of your period. Well, now, for tangent and cotangent, it will always be the distance of one full period, pi n. And then lastly is your range. And so your range this time goes on forever, all the way up into the positive numbers and forever down into the negative. So your range is just all real numbers. Goes on forever to negative. If you want to write negative infinity to positive infinity, by all means go ahead. Both answers would be sufficient. Okay, and then the last thing I want to point out is just our general equation for domain. So we wrote this back for secant and cosecant. Your domain for any cotangent graph is going to say all reals except, all right, x cannot equal, pick an asymptote, doesn't matter which one, plus the distance between your asymptotes, which will always be a full period for cotangent, n number of times. So again, this is denoting our distance between your asymptotes. Secant and cosecant, it happened to be half the period. Now cotangent and tangent too will end up being the entire period. Okay, that is the end of our discovery for cotangent. Click the next video to see a few examples.